Hi, everyone. I'm going to go over the homework 3, chapter 2 problems today, which are primarily problems dealing with free fall and a little bit of acceleration. So there's a little graphing on here, but hope you're all well. So in this first one, we have a ball bearing. So basically a still ball that's going to fall. And it's going to fall for 4.2 seconds in order to solidify. It's how high. And this is a free fall problem. We have a ball that is dropping from a certain height. We don't know what this height is, but we do know that it's going to fall for a time of 4.2 seconds before it hits the ground. And how we do any free fall problem is we list our 6 variables. Now, the first one we know is A is minus G. Our Y initial is the height of the tower, and that's what we want to find. Our Y final is the ground, so it's 0. Our V initial, we're not specifically told, but we're going to assume that they're falling from rest, which is 0 meters per second. We don't know V final, but we do know the time is 4.2 seconds. Yours might be different, 4.20, I should say. Now, I don't know V final, I don't want it. And remember, for our free fall or for our projectile motion in the Y, we have the following 3. We really have 4, but I'm going to use only 3 of them today. Following 3 equations, which are our free fall equations. And in order to find the height of this tower, we need to find Y initial, but we don't know V final and we don't want it. So that eliminates these 2. This equation has no V final, this has no time, this has no Y. So I'm going to use this equation right here to find the Y final. If I rearrange this slightly, I get that Y final minus Y initial, this is 0, is equal to V naught T minus GT squared over 2. This is also 0. So I have negative Y naught is negative G over 2 T squared. The negative signs go away. And therefore I get 9.8 over 2 times 4.20 squared, which 9.8 times a half times 4.2 times 4.2 gives me about 86.4 meters. 86.4. So all you have to do, really the problem is that you need to be able to write down your variables, and it's not obvious that they're starting from rest. It's obvious, maybe not obvious, that the initial position will be the ground, which is 0. So what is the impact speed? And now we are being asked to find V final. This is actually easy to find because V final is V initial is 0 minus 9.8 times 4.20. That is 9.8 times 4.20 is 41.12. The negative sign is because as this thing falls, right before it hits the ground, it's going to have a velocity of 1.2 seconds, but they just want the magnitude. That's what speed means, the magnitude of the velocity. Okay, so 41.2. And I only use 9.8 in that problem. All right, so for this next problem, we are going to have a rock. And this rock is thrown straight upward from the ground, and then it falls in a 10-meter deep hole. So this is the ground where Y initial is 0. It has an initial velocity of 15 meters per second. And we want to know, what is its speed when it hits the ground at y final? This was 10 meters deep, so that is negative 10 meters. And again, just start by the initial, the final, a, t, a is negative g. We know y initial is 0, started from the ground. We know y final is minus 10 meters. We know v initial is positive 15 meters per second. We want to find v final, and we do not know how long. So if we look back, this second equation has no time in it, so that is the equation that we want, minus 2g, y final minus y initial. We do not know our v final, but that's actually what we want to solve for. We know v initial, we know g, we know y final, we know y initial. So v final squared, move this over, just add it to both sides, is minus 2g y final minus y initial. This is squared. We're going to take the square root. We can choose the positive or negative, but again, they want the speed. So plugging that in, I get 15 squared minus 2, that 2 looks awful, minus 2 times 9.8. Y final is negative 10 minus y initial, which is 0. So under the square root, I have 15 times 15 minus a minus. This 10 is also a minus, so I get 2 or plus 2 times 9.8 times 10. Don't forget your square root. And I get 20.5 meters per second. Now this is actually negative 20.5, but they asked for our speed. You can round it up to 21 if you want, but it'll take 20.5. And then how long is the rock in the air? And so this part, you can do one of two ways. You can find how long it went up to maximum height, and then how long it took to fall. That's actually not super hard for the going up part. Okay, our y initial, our y final, our v initial, our v final, our a and our t, our negative g, y initial 0. We don't know what y final is. V initial is 15 meters per second. But at maximum height, v is 0. So v final will be 0 and t will be unknown. V final is equal to v initial minus gt. This is 0, move that over, and I get that v initial is gt, or t is v initial over g, which is 15 divided by 9.8. Now, on the way down, okay, I know that v initial is 0, and v final is, coming back to this, negative 20.5 meters per second. Y initial is unknown, y final is negative 10, a is g, or negative g, I guess, and t is unknown. Now, I actually don't know y initial, and so I can use this equation again with my new variables, and v initial is 0, so v final is negative gt, or this is the time up, the time down is v final over negative g, which was negative 20.5 over negative 9.8. And adding those things together, the total time is 15 over 9.8 plus, those go away, 20.5 over 9.8, or 35.5 over 9.8. You can add the top since they have a common denominator. And I get 3.62 seconds. Now, the only hard part here is that you have to actually do 2 problems. And if you didn't know v final, you would have to find the maximum height, which is a little bit of a pain. However, we could also do the total time So y initial, y final, v initial, v final, a and t, and remember negative g, y initial was 0, y final was negative 10, v initial was 15, v final was negative 20.5 meters per second, and time is what we want. In this particular problem, you could actually turn this into a quadratic. We're not going to find time. How you would do that is rewriting it as 0 is negative g to the half times t squared plus v naught times t minus y final minus y initial. This would be your A, your B, and your C. And then negative b plus or minus b squared minus 4ac over 2a and choose the positive time. We could do that if we want. However, since we have these, the one equation that we almost never use actually is useful here. So multiply both sides by 2 over v final plus v initial, and that will get rid of this. And so our time is 2 y final minus y initial over v final plus v initial, which is 2 times negative 10 minus 0 over negative 20.5 plus 15. Make sure you do your algebra right. You get negative 20 over negative 5.5, which is 20 divided by 5.5, 3.64 seconds, which was pretty close to what we got. We got about 3.6, which was the answer. There's a little bit of rounding issues here. You would want to use the actual unrounded v final for that. But you could do this 3 different ways, whichever way makes the most sense to you. And all of these free falls, sometimes there's 2 ways, sometimes there's 3 ways to find your answer. But the idea is write your 6 variables, choose the equation that's missing the thing you don't need. In this case, we have everything but time. So choose the equation with time that you want to use and then solve it. And that's it. We could also have done the following. Notice v final is v initial minus gt. Now v final plus v initial, I'm sorry, take that away. It's actually 4 ways to solve this. Minus v initial is minus gt, or t is v final minus v initial over minus g. So t is minus 20.5 minus 15 over minus 9.8, which is 35.5 over 9.8, and again, 3.62. So there's lots of ways you can solve your problem. By the way, if I have to pause this, my dog, I thought she broke her leg, but she sprained it really bad, and I was at the vet all day yesterday, which is why we didn't have a video yesterday. She's doing all right, but if she starts crying or freaking out, I might have to help her. She's on pain meds. All right, now this one and the next one are about acceleration and position. And specifically, this one is about using functions, and the next one is about using graphs. So we're told that the velocity function is 2t squared meters per second. Where t is in seconds, the initial position, initial time, initial position will be 1.7, and the initial time will be 0. And why do we want that? Well, we want to find at t is equal to 1.7 seconds, what is x? But we have a function b. We have v of t. And if you recall, v was dx dt. Therefore, we could rewrite this as dx is equal to v dt, and then integrate both sides, x initial, x final, v initial, v final. So I'm sorry, those are not the limits on v. The limits on v are t initial, t final. But t initial is 0, so I'm going to get rid of that and just call this t. We were told that. So what we get when we integrate this is x final minus x initial, this integral is just x, is equal to 0 to t of 2t squared dt. How you do this integral? Bring the power up by 1 and divide by the new power. So this becomes x final minus x initial is 2t cubed over 3 from t to 0, or we can get rid of that. That means our x final is x initial plus 2t cubed over 3. X initial was 1.7. T is 1.7 as well. And we get the following. 1.7 plus 2 times 1.7 times 1.7 divided by 3. And I get 3.63. No, I don't. Oh, this is t cubed. I'm so sorry, you guys. I'm dumb. 2 times 1.7. 2 times 1.7 times 1.7 times 1.7 divided by 3 plus 1.7 is about 5 meters. I just wrote t squared instead of t cubed. It's a simple integral. You should know how to do it. But yeah. For the next part, we're asked, what is the particle velocity at 1.7 seconds? But we already know that the velocity is 2t squared. So plug in 1.7. And what I get is 2 times 1.7 times 1.7, about 5.8 meters per second. That one's easy, right? And then finally, what is the acceleration at 1 point? Now, the acceleration is the time derivative of v. The time derivative of 2t squared is 4. The 2 comes down and you lose a power, 4t. So this is 4 times 1.7 or 4, 6.8. And those units are meters per second squared. So I just want to make sure that you know that the position change is delta x. The velocity is, or x of t, if you want to say. The velocity is the change of x over time. And the acceleration is the change of the velocity over time. But also, the integral of dv is the integral of a dt, usually from 0 to t, but we can write it this way. And then, essentially, this is a little bit weird, but x final over, x final over x initial. And this is t initial to t final of your velocity function, dt. So just make sure you know those, that you're aware of those. You probably won't have to do that on the test. However, there's also the graphical way of doing this. And so if we have an x versus t graph, recall that the slope of an x versus t graph is the change of y over the change of x, which is change of x over change of t, rise over run. The slope is the velocity, okay? Or a v versus t graph, the slope is the acceleration. But the area under the curve, area under, is the change of x. And then finally, for an A versus T graph, the slope means nothing, but the area under the curve is the change of velocity. And there's a trick here that we'll see in this problem, but so there's no area under the curve for x. That won't give you anything, but the slope will give you x versus t, will give you velocity. The slope of v versus t is acceleration. The slope of a versus t doesn't give you anything. The area under v versus t is change of position, and the area under a versus t is the change of velocity. We'll see how this works. The only thing you need to recall is that for a rectangle, length times width is the area. For a triangle, base height, it's 1/2 base times height. And if it's under the curve, it's negative. So we want to find the velocity at 6.5 seconds. Basically, right here, we want to find the slope. But notice this slope is the same. It's a constant slope from 2 to 8. You can pick any interval to get the slope. I'm going to go from here to here. Now my slope is my change of y. So this started at 30 and it ended at 0. That change of v, or I'm sorry, that change of x is x final minus x initial. Final is 0, initial is 30. And then the change of the time, if I look, this is 2 to 5, is 5 minus 2. So this is over t final minus t initial, which is 5 minus 2. And I get negative 30 over 3, which is my change of velocity, or my slope, which is negative 10 meters per second, meters over seconds, which is negative 10. All right. This part's a little bit harder. And that's because we're going to find the area, but, okay, the area is essentially, so if we have some v versus t, what we find here, this area is v final, okay? V final plus v initial is, this is our area plus v initial is our total, don't do that, sorry. I wrote that, kind of weird. V final plus delta v, and this area is delta v. So our v final is the change of v plus whatever the initial value was. So we need to have an initial value for the velocity. And it turns out that in this, they tell us at t is equal to 0, our initial velocity will be 10 meters per second. Okay. Now, we want to find the velocity at 6.5. So we're going to go to about right here. And so what we have is we have 3 triangles. We have, or I'm sorry, we have 3 areas. We have this first square where the bottom is 2 seconds and the top is 30. So the area of this is 30 times 2. Then we have a triangle that goes from 2 to 5. So this is 5 minus 2, or 3. And it goes from 30 to 0, which is again 30. We just care about the area. This is 3 long, and we'll look at that again. And it's 30 high. From the triangle area, this is 1/2 base times height, or 1/2 30 times 3. And then finally, the last one that we have to be careful. So we're going to go 5 to 6.5, but this is actually negative. So we're going to go 1.5 seconds. And we're going to go negative because we're below here. And if we look at 1.5, we're at negative 15. So by the 1/2 base times height, this is 1/2 times 1.5 times negative 15. We're going to add all these together. So our V final is our change of V plus our V initial. Our change of V is these three things. So 60, 1/2 of 15 times 3 is 45. 1/2 of 1.5 times negative 15 is 0.5 times 1.5 times 15 is negative 11.25. Add all these together and I get 60 plus 45 minus 11.25. I get 93.75. But I'm not done. I have to add my initial velocity of 10. So I basically get 104 meters per second or 103.75. So that's the one weird trick that you got to kind of do here. Know that the negative, the ones below the x-axis are negative. I'm sorry, yeah, below the 0. And that you need to add the initial velocity to the change to the area under the curve to find V final. If you just wanted the change, it would just be 93.75. All right. And they rounded to 100 for 3/6. Just in case you're wondering. All right. Now, this problem is actually easier to do by looking at this. So, how far is this going to travel? Basically, it traveled 10 centimeters and it lost half of its initial velocity in that time, in the same time that it traveled a third of the distance, okay? Now, if you think about this, so it had 30 centimeters. It starts here with V initial. After traveling 10 centimeters, okay, so after traveling a third of that distance, it has fallen to V initial to the half. In that same amount of time, it's going to go, or I should say it went from V initial to V initial over 2. In that same amount of time, it's going to go from V initial, let me rewrite this. It went from, its change of V was, oh my God, my brain's not working today. V final minus V initial. So it went from V initial to minus R to V initial to the half. So this is negative V initial to the half over some time. So this is my acceleration. So in the second amount of time, it's going to come to rest, right? In 2 time intervals, it's going to stop. What we need to figure out is, if I think of this as 10, 20, 30, okay, in the first interval of time, it went to 10. And then I need to figure out how far does it go in the second interval of time. Well, the thing is that in the second interval of time, it decreases from its change of V over change of T is going to be V final minus V initial, same delta T, and V final is 0. This is negative V naught over to the half over delta T. So its acceleration is going to be the same. However, its distance is going to be significantly shorter. It's actually going to turn out that if we think about it this way, okay, so x final minus x initial is V naught of T plus a T squared over 2. And in our first time, in the first second, a is negative V naught to the half, okay? And V initial is V initial. So I get x final minus x initial. This goes away. and I get V initial t plus a t squared over 2, but I'm going to change this to negative V naught to the half, V naught to the half. And I know this was 10. I don't know what V naught was. I'm going to assume that t is 1. So I get V naught minus V naught to the fourth. And so what I get is that V naught was 3/4 is equal to 10. So V initial was 40 over 3. Okay. Now, in the next part, I need to find x final. Minus x initial is V naught, but V naught is actually half of this. Okay, 40 over 6. Let me write it this way for you. So 40 over 6. No, I don't want to write it that way. Sorry. V initial to the half times t minus a plus a. Now, I'm going to actually go to it. So x final minus x initial is V naught t plus a t squared over 2. V naught was 40 thirds meters per second. But here, this V naught for the second trip, x initial was 10. V naught was half of the original V naught. So this is 40 over 6 meters per second. A was negative V naught to the half. And so that is negative 40 over 6. And our time we'll assume is again 1 second. So x final is x initial plus V naught t plus a t squared over 2. X initial was 10 plus 40 divided by 6 times 1 minus 40 divided by 6 divided by 2 times 1. And so what I get here is, if I look at this, I get the following. I get 10 plus 40 divided by 6 minus 40 divided by 12. And I get 13.33 meters. Okay. I know it's weird. And it would seem like in your head that what you can do is think about, okay, well, it went a third of the total distance and lost half of its speed. So it should go a third of the total distance again and lose half of its speed. However, it's not that simple to actually prove it. How we proved it is by doing the following. We just use x final minus x initial is V naught t plus a t squared over 2. We know that a was the change of b over the change of t, and the change of b was V naught to the half with a negative sign. It lost half of its speed. We can say t is whatever we want. We'll call it 1 second. Okay. Then x initial will choose to be 0. T will be 1 second. A will be negative V naught over 2. And from this, we're also told that this is 10 centimeters. You can rewrite that as, just leave it as 10 centimeters. This will be in centimeters per second squared. Okay, so by doing that, we find that the V initial is 40 centimeters over 3 per second. That was just from the first one. In the second part, x initial is now 10 centimeters. And we're going to find x final. So x final is x initial plus V naught for the second part, t, plus a over 2. And by plugging these in, this was 10 centimeters. V naught for the second part, though, is only half of the original. So 40 divided by 6. T is again 1, so it's centimeters per second. And A was negative 40 divided by 2. I'm sorry. It's- do, 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 do. This is 40 divided by 3, because that's V naught, divided by a half, and times 1 second squared. Now, doing all of this, you'll get 13.333 centimeters. Okay, that's how you do it. And it now has a velocity of 0. It comes to rest at 13.3 centimeters. The reason why this is 3.3 is they're asking you how far it goes in the second half. It only travels 3.3. Obviously, if it can travel, if it can go 10, 20, 30, the pad is 30 long. In the first delta t, it traveled 10 centimeters. In the second delta t, it traveled 3.3 centimeters, and it stopped. Its initial velocity was 40.3. When it got here, it was doing 40.6 centimeter per second, and when it got here, it was doing 0. So it doesn't roll off. It's a really weird problem. It's a really hard problem, honestly, super hard. But it's worth talking about. All right. When we have an incline, when we talk about this more, and we'll talk about this more and more, along the incline, going downward, if the incline is at some angle, the acceleration is down the incline at g sine theta. It's a vector, it points downward, and it's equal to g times sine of whatever. What we have is a skateboarder starts up a 3-meter long ramp at 3.2 seconds. So if we turn this on its side, we're going to assume that up is positive. It's 3 meters long. I don't even think we need to know that. The acceleration is g sine theta, and it's negative. So we're going to assume that x initial is 0. X final is unknown. It's what we want. V initial and V final. And then A and T. Now A is negative g sine of theta. V initial, we're told, was 3.2. And now we have to be a little bit careful. What is the maximum height of the ramp? So we need to find how high he goes up before his velocity stops. He's going to roll upward and eventually stop for an instant in time and then roll back down. So his V final will be 0. Once we find that, we're going to have the hypotenuse. And what they're actually going to ask us for is y at that point. So y will be x final times sine of the angle. That's what they actually want. So our angle is unknown. And so this actually means that we don't know our angle yet. We're going to have to find our angle. Okay. Or actually, it's probably going to cancel as y. Okay, so let's think about this. So V final at the top. We don't know x final, but what we actually want to find is x final. And we don't know time. We have V final squared minus V initial squared is 2a x final minus x initial. And I'm going to move to a new one. V final squared minus V initial squared is 2a x final minus x initial. We're going to solve this for x final. Divide by 2a, add x initial, but since it's 0, I'm going to just neglect it. X final is V final minus V initial over 2a. X final is 0, x final squared, sorry. And a is negative g sine theta. So this is negative V naught squared over 2 times negative G sine theta. However, remember, we want Y. And Y is equal to X final times sine of theta by trigonometry. This part, if this is our hypotenuse, then this part of our hypotenuse, or this part of our triangle, is the hypotenuse sine of theta. This is H sine of theta. But our hypotenuse is however far he goes. So this is X final sine of theta. If I plug that in, then I get X final times V naught squared over 2G times sine of theta over sine of theta. And my angle cancels, and I don't even need to know the angle. All right. Oh, I'm sorry, and I'm being dumb. There's no X final in that. So my height is V naught squared over 2G. And that was 3.2 squared over 2 times 9.8. So 3.2 times 3.2 divided by 2 times 9.8. And I get 0.52 meters. So about half a meter, 0.52 meters. All right. It's kind of weird. This problem is actually super easy once you do it, but there's a lot of little pitfalls on it with the angles. Again, I like homework problems that are a little interesting and a little challenging, but not super hard. Okay, so this next problem is the hardest type of Prepaul we can have. Nicole throws a ball straight up. Chad is watching from a window 6.1 meters above the point where she releases it. The ball passes Chad on the way up and has a speed of 12 meters per second as it passes him on the way back down. So we want to know how fast did Nicole throw the ball. So let's try and picture this. This is where she releases it. We don't know the initial velocity. We do know that at a height of, let's call where Chad is Y, and Y initial we'll just call 0. So as it goes up and comes back down, as it passes this point, its velocity is 12 meters per second. So first of all, Y initial, Y final, V initial, V final, A and T. Y initial is where she threw it. We called that 0. Y final will be this. We're not even going to worry about coming back down yet. 6.10 meters. V initial was unknown. It's what we want. V final was 12 meters per second. We know that A is minus G, and we don't know time. So V final squared minus V initial squared is minus 2G, Y final minus Y initial. And we want to find V initial. So in this case, negative V initial squared is equal to negative V final squared, subtract V final squared from both sides, 2G, Y final minus Y initial. We do know it'll be positive. All the negative signs cancel. V initial is V final squared plus 2G, Y final minus Y initial. Square root is squared, and we're going to take the positive root. So that's the square root of 12 squared plus 2 times 9.8. Y final was 6.1, Y initial was 0. This is 12 times 12 plus 2 times 9.8 times 6.1. Don't forget to take your square root. And I get 16.2 meters per second. It better be greater than what Chad noticed as it passed him, because it's going to lose velocity as it goes up. 16.2. Okay. Was there a part B in that? Nope, only a part A. And finally, this is the one I was thinking of. The final one is our revisiting our police officer, our chase. Where did it go? So revisiting our case. David is traveling at a velocity. This is David. He is traveling at v is equal to 27 meters per second, constant speed. Tina, who is at rest, begins to accelerate at 2.9 meters per second squared. Her initial velocity will be 0. Right as the instant that Dave passes. So they're going to both travel a distance because David's velocity is constant. A for David is 0. V initial for Tina is 0. But they reach the same final position in the same time. So let's write Tina's equations or variables in David's. Tina, x initial will be 0. David's x initial will be 0. Tina's x final is unknown, but we're going to find it. And we know that these two things are the same. Tina's initial velocity is 0. Tina's final velocity is unknown, and we're not going to actually want it. And Tina's acceleration is 2.9 meters per second squared. Time is unknown, but they're going to have the same time. V initial and V final for David are just V of David, which is 27 meters per second. A of David is 0, and T is unknown, but again, these two things will be the same. So basically, we need an equation for x final for David, which is the case when A is equal to 0. David has x final minus x initial is equal to V of David times T. For Tina, whose A is 2.9 meters per second squared, we have the following. We need time and we need x final. So what we're going to use is the following. X final minus x initial is V initial of Tina times T plus A of Tina times T squared over 2. Okay. Now we can get rid of x initial on both of these guys. In fact, we can also get rid of Tina's velocity. So because her initial velocity was 0. And x final is A for Tina, T squared over 2. So we can either find time or we can either find x final. Now, one way you could do this is how far. So we just want to know x final. And then in the second part, we want to know T. I'm sorry, we don't want to know T. We want to know her final velocity. And we'll find that in a minute. Okay, so we want to find x final. We basically want to solve this for T. So it seems like we're taking an extra step, and we are, just to make it a little bit easier on us. Set this x final equal to this, so set the equations equal to each other. And what you get is the time. 1 power of T cancels. So this goes away. And then if you divide or multiply both sides by 2 over AT, you get your time. So your time is 2 times David's velocity over Tina's acceleration, or 2 times 27 divided by 2.9. The time that they travel, 27 divided by 2.9, is 18.62 seconds. 18.62 seconds. Now that we have that, since it's the same, V of David is 27 times 18, or x final is V of David times the time, or x final is the acceleration of Tina times the time squared over 2. And if you do that, you'll get the same answer. 27 times 18.62 is 13. No, it's not. 27 times 18.62 is 502, 503 actually. And 2.9 times 0.5 times 18.62 times 18.62 is 503, just like we thought. So they end up 530 or 503 meters away when Tina specifically passes David. Now, looking back at this, because Tina has an acceleration, V final is V initial plus AT, but Tina's initial velocity was 0, her A was 2.9, this was 18.62, and her velocity at that point is 2.9 times 18.62, 53.99, 54 meters per second. Okay. But the reason why I'm giving you this problem is this is basically what we do with all the projectile motion that we did this week. In the Y, you are Tina. You have an acceleration of minus G. And in the X, you are David, and they are linked by their time, not their X final. In this problem, X final is the same for both of us. So anyway, that's our homework. I'll try to get your worksheets and quizzes graded by class on Tuesday. I hope you all enjoy the Super Bowl if you're watching it. If not, and if I don't see you, I hope you all have a wonderful Valentine's Day. Otherwise, I'll see you Tuesday morning. Bye.